Okay, so in our notes 34, says we're going to review. So let's do that. It says review. How many meters are equal to 680.2 inches? Show all your work. So this is a problem we did at the beginning of the year. Dimensional analysis. I use my units and I cross out units until I get to the right one. How these problems always start is start with the number that's given. And be sure to write down the unit. Fight this every year. If you don't want to write down the unit, you think it's not going to be important. It is. It matters. I don't know what to do next if I don't put the unit down. Okay, so we just have our little number. That's what they gave us. Now this is just like the warm-up problem yesterday. I want to get rid of inches and get to meters. My goal is a different unit. If I want to get rid of inches, I need to be on top and bottom of each other so they cancel. So if inches is technically on top, they're always on top of one. I don't usually write the one because I just know it, but if you need to write it on top to remember it's on top, then write it on top. Put a one on top of it. That helps you remember it. So now the inches are on top. I need to put the inches on bottom so that they will cancel. The unit that I want to get to, meters, if I have a conversion factor for it, meter to inches, I do. I have a conversion factor given to me, so then I can go from inches to meters. How I get from inches to meters is to put in the conversion factor. So how many inches are in a meter? Just if I ask you to turn inches into feet, there's 12 inches in, or there's 12 inches in a foot. So it says right here that there's 39.37 inches in 1 meter, which is what it says. That's conversion factor. It's nothing you have to memorize, it's just what it is. Now, if I already have inches canceled and I'm left with meters, and meters is what they asked me for, and I'm done with the setup, and I just have to put this in the calculator. Okay, so I'm going to stop now and just put this in the calculator. But what this is telling me to do, fractions, 3rd grade, multiply the top numbers, you divide by the numbers on the bottom. So when I put this in the calculator, it would go 680, so 680.2 times 1. I don't really have to type that in, but I'll do it. So times 1, and then divided by 1 times 3, 39.37. I don't really need times 1, so I'm just going to divide it by 39.37. And my answer is 17.27. We're just going to round it to an 8. So I want to keep it at that 2 decimal places. And the only unit I have left is meter, so it's 17.28 meters. So if I have 680.2 inches, and I draw a line that's that long, 680 inches, it's 17 meters. And a meter looks like this. It'd be 17 of these. It'd be the same as drawing a line 680 inches. It'd be like having 17 of these in a line. Okay. Let's move on to moles now. Okay, so that's just how we used to set up problems. We're going to do that same setup, just with a new unit. New unit you had never heard of till this week, called a mole. And a mole means 6.02 times 10 to the 23rd of something. Okay, clear ink. So just like I had before, where I had 39 inches in 1 meter. Well, now it's asking you to write the conversion factors for things with moles. Generally, we're always going to work in grams, because that's what most of our scales work in. It's just how easier to work in science in grams. So we're going to work in our grams for molar mass. So if I want to have good conversion factors for molar mass of the following, I need to find their molar mass first. So yesterday we learned how to do that. If I have sodium, I look at my periodic table. Show you again. I look at my periodic table. I'm going to find sodium's mass. It's 22.99. So if you don't know that, then you look it up. 22.99. I'm going to write it down. I'm going to add it to whatever chlorine's mass is, which I know is 35.45. So the mass of chlorine on the periodic table is 35.45. We will add those things up, and that'll be our molar mass. We did yesterday, just adding up our molar masses. This is actually one you did yesterday. Pretty sure it's 58.44. 22.99 plus 35.45. Yeah, 58.44. Okay, so the molar mass of this is 58.44 grams per mole. But how I really am going to write this conversion factor in these problems that we're going to do is I'm going to write on the top of each other like a fraction. So it will look like 58.44 grams over 1 mole. So it says mole, but it's assumed. It's like you should assume it's 1. Wouldn't be written there if it was 1. The other way I can write it, this is how we were doing it at the end of the year. I can also write them flipped upside down. If 58.44 grams is equal to a mole of NaCl, then so is 1 mole of NaCl equal to 58.44 grams in the bottom. Both are true. It doesn't matter which one is on top of each other. They are equal. 1 mole of NaCl equals 58.44 grams. They are the same. So I can write them on top or bottom, whichever one I need in my problem. Okay, so a little slightly more complicated. So we're going to find barium. We're going to add it up, add it to oxygen, hydrogen. So barium, that one I don't. Let's see. Barium is 137.33. So 137.33. It's a big, heavy atom. I'm going to add its mass to oxygens, but oh, there's a 2. Remember that 2 goes to everything inside the parentheses, so there's 2 oxygens. Oxygen's mass in the periodic table is 15.99, but that rounds up to 16. So it's going to be 16 times 2. We're going to add it to that. So we're going to add it to 16 times 2. And we're going to add it to hydrogen's mass, which is 1.01 when it rounds up. So 1.01, but also there's 2 of them times 2. So a little more complicated with the parentheses, but still it is just adding up numbers. So I have 137.33 plus parentheses 16 times 2 close parentheses plus parentheses 1.01 times 2 close parentheses. And I get 171.35 grams per mole. But again, I want to write this like a real conversion factor, one that I might be able to use down below. I will use it down below. We are doing helpful work for ourselves in a second. So how I would really write this is 171.35 grams is to 1 mole of BaOH, this thing, BaOH2, barium hydroxide. If I had a mole of it, if I had 6.02 times 10 to the 23rd formula units of barium hydroxide, it would be 171.35 grams in weight. I could also write it the other way. If I needed to be the other way to cross out the correct units, then I could write it as 1 mole of BaOH2, barium hydroxide, over 171.35. 0.35 grams. Okay. Now, we're about to use those. So that's just molar mass we did yesterday, but now we're writing them like a fraction because I need them that way to solve my problems. Oh, how I wish moles could solve all my problems. It'd be so simple. You just multiply. Okay, so I'm going to erase this. Here we go, moving down. Y'all are going to have to remember what the masses are. Hopefully, y'all wrote it down. I don't want to add them up again. So how many grams are in 2.5 moles of NaCl? We start this problem. All the problems that we did in the beginning of the year, like the problem I just did, like the problem I did yesterday in warm-up. You start with what is given. 2.5 mole of NaCl. I know it is annoying to have to write all that out, but it is important. It helps you not make mistakes. You know what it needs to be, the compound that it is matters. So we write it off. I start with what's given. I multiply by a line. We know it's going to be a fraction. I don't want to cancel units. The unit that it asked me to get to, I want to go from mole to grams. So it's saying, what if, so yesterday y'all weighed out 1 mole of something. You weighed out 1 mole. Well, what if I don't need 1 mole in my chemical reaction? What if I need 2.5 moles? What if I need 1,700,000 moles of it? Or I can't do my giant reaction, whatever it is. Most of the time, you don't need exactly 1 mole. Most of the time, you have to have a piece of like 2.5 to figure out what that would weigh. So how I set that up? If mole is here, where does it need to go? Top or bottom? Bottom. Whatever is on top must go on bottom because I want to get rid of it. So it's going to go there. Now, if mole is on bottom, we're sticking to 1-steppers for today and tomorrow, all 1-steppers. So if this is on top, then what I want to get to needs to go on top. So what is that? Grams. Grams is going to go on top. Now we will get to the point where there will be two-step problems, but that will not happen until next week. So all this week, if you put this on bottom, the unit you want will be on top. So moles is now going to cancel and grams are what I'm left with. But what numbers do I put here? It is the conversion factors that we wrote on the previous above section. Okay, so what I put here is molar mass. What is the mass of 1 mole? So every single time we do these problems, when you have a mole on the bottom or a mole on the top, you're multiplying by something over a mole. It is going to be a 1. That will not change for this entire unit. It will change in the next unit. It will sometimes be things other than 1. But for this entire unit, we're comparing it to 1 mole. So if you write a mole in your conversion factor, it's going to be a 1. Now, what is the grams is your molar mass. What is the molar mass of what we're dealing with, NaCl, which we already saw up above. So I add the mass of Na, I add the mass of chlorine. It was 58.44. So I plug that in. 58.44 grams is equal to 1 mole of NaCl. We already know that. We wrote that conversion factor above. So now the mole cancels. I have it set up. Grams is what I'm left with. Grams is what I want. I just got with the calculator. You multiply the top, divide by the bottom. The bottom happens to be a 1. I don't need to actually divide them. So I really just multiply. 2.5 times 58.44, and I get 146.1 grams. Well, grams of NaCl. Let's be specific. That's what I have grams of. So if I needed 2.5 moles for my reaction with salt to work out, I would need 146 grams weighed out. So yesterday, like you were weighing out the 58.44, you would need to weigh out 146.1. All right, let's do that one more time. We got our bigger one. Same deal, it's just going to be backwards. We're going to start with grams instead. Now I want to go from grams to moles. So like always, I'm going to write down what's given. I got 125 grams of BaOH. That's what I have. I have these grams. They're saying, how many moles is that? Okay. So if I'm starting with grams, what's going to go down here? If I'm starting with grams, right? Okay, so whatever you start with is what you are putting on the bottom. Always start with getting your units correctly situated. If I have grams on the bottom, I told you this is a one-step problem, so then what I want is going to have to go on top. What I want is moles. You can shorthand moles and put MOL. That's fine. Okay, now that I have it set up, it's just this. It's the same as we just did, except for it's upside down. They're just flippy-flop. So now I want you to look up, because I already erased mine. What was barium hydroxide's molar mass? 171. What? 0.35. Okay, now notice, the big number last time was on top because it went with grams. Now the big number is on bottom because it goes with grams. So whatever you're adding up on the periodic table, the molar mass that you add up from the periodic table goes with the gram unit, and the number that goes with the mole unit is 1. Always for this unit, it's going to be a 1. And it is moles of BaOH, barium hydroxide. Now, grams will cancel. Bam, bam, it's gone. It's leaving me with moles. Moles is what they asked me for, so I know I am ready to just put this in the calculator and get the answer. I now have 125 times 1. Don't really have to times it. I know what it is. It's 125 still. But I divide by 171. Since the big number's on the bottom, divide. The big number's on top, and multiply. In this case, we divide. So 125 divided by 171.35. And I get smaller number because we're dividing 0.72. Actually, I just want to keep it in 2 decimal places. So that's going to round up to 0.73. And that will be mole. 0.73 moles of barium hydroxide. That's how many moles I would have. I wouldn't even have a full mole. So if I ask you, do I have 6.02 times 10 to the 23rd formula units? No, I don't have a full mole. I have less than a full mole. I'd have to take that number, 6.02 times 10 to the 23rd, and multiply it by 0.73. And that would tell me how many formula units I have. All right, so that's notes. Pretty sure. Let's scroll down. Anything else? No, that is notes for today. There we go. Clear that. Stop recording.